Tutorial, and in this tutorial I'm gonna introduce you about the UI test or user interface test. And as you know that UI test is pretty much related with testing your user experience, like you can simulate your user journey and verify the interaction between different modules of the applications, right? So there are also actually this UI test is also referred as end-to-end test. Okay, for small application you can have one test suite, but for larger application you should split your test suites to cover user journeys. Logging in, like for example, logging in is also one of the test suite, or you can create an account test suite, or you can setting set of flows, some kind of a flow of your application, and so on. So these are kind of a UI test suites. Okay, and actually this test lies in Android test package, because obviously it will run with the instrumentation framework. So the app is actually built, how it is working, the is it's working as follows: the app is built and installed in the device. The testing app will also be installed on the device that will monitor your app, and the testing app will execute the test on your app and record the result, right? So but there are some drawbacks of this test, is like this test will share persistent data. So if the test stores data on the device, and then the second test can have access to that data, which means that there is a risk of failure, right? So another drawback is that if test comes across a crash, this will stop the entire testing, because the application under test is stopped. Okay, so these issues were solved in the Jetpack updates with the introduction of the orchestrator framework. So orchestrators give you the ability to clear the data after each test is executed, sparing developers the need to make any adjustment. The orchestrator is represented by another application that will manage how the testing app will coordinate the test and the data between the test. Okay, in order to add this orchestrator to your project, you need a configuration. Okay, so the configuration of your application will be similar to this one. What you have to do is inside your debug section, inside which is inside the Android section, inside your debug section, you just need to add a test instrumentation runner argument, and with the clear package data set to true. And obviously there is like also like you have a test options with executions, has a value of a Android X test orchestrator, right? Okay, so this is the situation, and obviously you will be seeing here, you will be seeing here like there is a I'm using a custom test runner, right? Obviously we will be also learning how to create a custom test runner, okay, in a while. But the dependency that you have to use for your orchestrator is okay, this is the dependency that is inside the that you have to declare as Android test util. Okay, so it's like a utility for your test. Okay, and you can execute the orchestrator test on the command on your connected device using a Gradle connected check command, either from the terminal or from the list of Gradle commands. So let's go to our terminal and let's run this command, Gradle w, and we have to run our command called connected check. Okay, if I run, you see there is it's running, and what it's gonna do is it's gonna run the execute the orchestrator test on the connected device. This is my connected device, and it will be executed. So what's happening here? Build failed with an exception, did not complete. What was the situation? Did not complete instrument test bundle. Okay, what's the situation here? Okay, maybe some of the tests were failing because I still am okay, let me check out. the situation. This is my testing expresso activity robotic. Okay, I have a runner, custom test runner. Okay, obviously it might be failing because I'm using a custom test runner. And so okay, I will be teaching you how to create a custom test runner. Your custom test runner looks something like this one. Okay, instead of a Android test runner, as you can see, I'm using a custom test runner just built by extending this Android JUnit runner. So you are actually giving a new application called my application. Okay, but I have this my application as this scenarios. So let's go and solve it step by step because our tests are failing. And okay, so okay, step by step. One second, guys. Let me go to my Android manifest. My application. Okay, this is my application, and I have a okay. So actually okay, to make things clearer, what I'm gonna do is I'm gonna create a simple application for testing the UI. So what I'm gonna do, my application will consist of two activity. It's a application that has two screens. The first screen, okay, let me actually run the application. Actually it will be consisting of the two screens. The first screen which have a button. When the user presses the button, it will wait for the random time between 1 and 5 seconds, and then launch the second screen, which will display the text open. Okay, so this is my first activity, or first screen, you can say. So when I user press the button, it will wait for a random time between 1 and 5. So let me just first implement this, okay, and then I will go on to creating the custom test run, okay, slowly and slowly. So let's go step by step. This is my activity, and like find view by ID, it's a button. T1 button. Okay, so set on click listener, and application as my application synchronizer, and execute after delay. So it will just start your activity after a delay. Activity 2 with the random number, right? So new, actually I still have to implement the new intent. So let me go to an activity 2 and implement this new intent situations. Where is my activity 2? So activity 2 will also find view by ID. It's a text view, dot id dot activity 2 text view, text equals to get string, string opened. Okay, so we have here we have to also get the string, right? So let me get the strings actually. Okay, let me go to the string. The strings is, this is strings file actually, and let me define the strings open after this sequence. So what I'm gonna do is I'm gonna open my another second activity after some seconds, random seconds, right? Intent get int extra, and okay, I have to also declare my extras here. Private const val extra seconds as extra seconds. Okay, so you have a extra seconds, constant modifier. Okay, so actually I have to into companion, I have to declare inside a companion object. uh, const, so now you can make it as a constant, and then you have to create a new intent, context, context seconds, is, seconds. Sorry, I was writing fun, man. This was okay. Let me write, and then now what we're gonna do, we're gonna create the our new intent, which will pretty much pass as the context and activity2 class just java, and put the extra, which is gonna put the extra seconds as a extra seconds. Okay, so yeah, we have our and we get the extra seconds, and the default value is 0 if not no seconds is passed. Okay, right, so we have the activity new intent context is this is the context, and the seconds that we're gonna pass is obviously generated by a random, this one execute after a delay, okay, of this random. So this synchronizer is are pretty much like is a synchronizer class which will use a randomizer and timer to wait for a random time interval, and it will also use a kind of a have a randomizer timer, and also it's gonna use the private well counting idling resources, counting, yeah, but for the moment we are not getting that because of the value. Okay, so let's not use that for the moment. Okay, let's go to our okay, so we have our just activity 1 and activity 2 setup, right? So step by step we'll be checking out our custom test runner. Okay, so our custom test runner will be just passed with your application, right? But not your application, actually your test application. So we have to go and change this. Kotlin test runner is inside your, it should be inside your Android test folder. Okay, custom test runner, and you also need to have your let me create a your test my application. Okay, so your test my application will be obviously extending your my application, and it is gonna override create a randomizer, and it's also gonna override create synchronizer, and what else, make my application as a open, right? So let's go and make it open. Let me just close this so we'll have a nice overview of the entire code blocks. And then okay, so what next is, like, we have the application now. We need to create our test my application. Now we have to just use our counting idling resources with the timer resource. Okay, and then your create random will create the test randomizer. Okay, so we have to also create another one, class called test randomizer. Let's create the test randomizer class. Okay, your test randomizer class is obviously gonna implement your randomizer and override get time to wait, right? Get time to wait, and here is gonna return 1 as a value. And overall we also need to create the extra another one which is called test synchronizer chronizer. Okay, so obviously here also we're gonna use the chronizer, and here we're gonna have to uh, uh, here we have to override the execute after delay, and let me pass the necessary values here: private val synchronizer and private val counting link resources. Okay, and you have this synchronizer and execute after delay with the callbacks, right? And so we have a counting link resource for increments, and finally the synchronizer with executes after a delay, and the callback is called passing the delay value, and counting idling resource will decrement, right? So this is the situation. So okay, so what's happening here actually is we are pretty much test actually don't like randomness, so we need to eliminate it by making the randomizer class open and create a subclass of a android test directly. So we can do the same for our my that we did the same for our my application, right? So this is just to avoid the randomness in our test. Okay, the main motivation of creating this synchro sync, okay, synchronizer, to the main motivation to create a test synchronizer, test randomizer, uh, test my application, the motivation was just to avoid the randomness. Okay, because the test doesn't like the randomness. All right, so yeah, this was the motivation. So now what next is we were able to create the yes, now so we need to test application, test randomizer. Okay, so let me go back to my test my application. So here we create the test randomizer, but we still need to implement the test synchronizer and pass the super to create synchronizer dealing resource, and you have to pass the yeah, you just need to pass the counting idling resource because you just need that, right? So here we have our test my test application, and in your custom test runner we need to pass a test my application, right? So this is our motivation, and now this custom test runner is gonna we are gonna pass it to our build.gradle here. We need to pass our custom test runner here, okay, instead of our android JUnit runner. So this is our motivation, and okay, what next? Let me see first. Okay, so yeah, we created our the necessary setup. Okay, so what next is we also learned about how to create our custom runner, test runner, right? So um, okay, let me check out what we can do. Next is yeah, we successfully were able to create our custom test runner. Okay, so we will be, instead of using the custom test runner, no, instead of using the genuine test runner, we are going to use the custom test runner, right? uh, so now our situation is, have to create our test, right? So we have to create our test. So let's create our test. The test for our, yes, let me see, where is our testing file. Yeah, this is our activity. So we have to actually test our entire flow, right? So flow, because actually, what is happening is like, okay, let me run the application and show you the scenario. The scenario is like, we have our activity 1 with the button. When we press the button, it will wait for the random time and then go to the second activity where it's open after 2 seconds, like, the random seconds, okay, let me press again, and it's come after random. Okay, again opened after 2 seconds. Let me do it again. Okay, open after 4 seconds. So it's all opening. The activity second is opening after random 4 seconds. So now we have to test this scenario, right? So okay, how can we test this scenario? To test this scenario, we have to create a class. Okay, obviously, no, not inside my runner, it's just this one. Let me just testing. Okay, this is integration. Let me create another file, package UI. Okay, so let me just move it to the UI so that it sounds much better. Okay, so inside our UI folder, so we have to create our another test, which is obviously for our flow, testing our flow, right? Flow test. So it's this flow test. Okay, will you just need to verify your test, right? Just you write your test in this similar manner, you verify the flow. So this is the situation. So when you verify your flow, obviously it's gonna run with your Android JUnit 4 class, and when you verify your flow. So how you verify your flow is like, you have to check out the views, right? So we will use the on view from Expresso, this view. Okay, we have to use our view matchers like with ID, with ID, and we will use our view matchers to match with our respective ID, right? Okay, I don't know why it's like I'm getting a problem with my okay, let me import my resource. Okay, so r.id activity 1 button. Okay, then what we have to do is we have to perform certain view actions, right? Like click, because obviously we are gonna click this button. Sorry guys, let me just close it and we can have a nice view. Okay, so on view again, with ID matchers to match the ID, the activity to text view, we have to now check, and we have to matches. Let me just use this assertion, view assertion matches with the text my application. So how can you get your application? You can get your application private val my application will be get application context, and let's just import it and pass your type is a test my application. So my application get string and pass your the string dot opened after x seconds, and you pass just one, right? Yeah, so this is our simple test, like as you can see here, the test classes themselves can be written by applying the JUnit 4 syntax with the help of Android X test extension JUnit runner, right? Android JUnit 4 test runner. So we are running with actually JUnit 4 test runner, as you can see here, and then the test method themselves run in run the dedicated test here, and so actually Expresso is really helpful here because we are using all this Expresso's mechanism of view matchers, view actions and view assertions to verify our UI test. Okay, and what next is like uh, typically in UI you will find interactions and assertions that may get repetitive, right? In order to avoid duplicating multiple scenarios in your code, you can apply a pattern called robot. Okay, so each screen will have a associated robot class in which interactions and assertions can be grouped into a specific method. So your test code will use the robot and assert them. So one of the okay, let me create some robot example classes. Like the robot classes can be when the your test is very large and when it can be repetitive, then you can just create your robot classes, right? Like for example, you can create my screen robot. So it's just for the demonstration purpose, right? For the explanation. So we'll just create our robot, my screen robot, and which will pretty much on view oh sorry guys, actually I created here, but actually it's not here. You should create the robot classes not in your Java code. You should create it inside your Android test folder. So let me create here the robot class, my screen robot. Okay, so your my screen robot will be consisting of some repetitive test codes, right? Like my set text, like my screen robot, setting text, like on view matchers, view matchers, then with id r.id.edit. Okay, I'm not able to get this id, and this is crazy, but yeah, obviously we can do copy and paste from the id here. Okay, so you can just do a repetitive like view matchers, like edit text. Like for example, I'm just giving you some example, like if edit text, you perform something that is like view actions dot replace text with 5 and return this, right? So this can be robot, like you can press button, you can press your button, like my screen robot can perform like view matchers with the id r.id.button, perform view actions and click, right? And obviously you return this. So these are simple examples of your robots, right? Which are pretty much repetitive code, like for testing. So you can just pretty much use in this kind of scenario. So so when you are using it, how do you use it? You can pretty much use it like a robot uh, use case. Okay, so you can use it, for example, my screen robot in this manner, like set text, set press button, and also, okay, sorry, we can also write some kind of a final situation, like our assertion. Assert text. So how can we assert is my screen robot. So on view, view matches with id, with id, id dot rb text view, and we have checked the view assertion matches view assertions matches the view matches with text and my text, right? A test, right? So yeah, because you're replacing this with 5, and then you're gonna check if it on this, right? Okay, so yeah, you can just use set text, and assert text. So you can use this kind of robotic way of using your UI test, right? I mean, doing your UI test. So this is also another way, and which will make your test more concise and more readable. And sometimes, like, you can, if your code is repeatable, you can just pretty much reuse this, right? That's the main goal of using robot. So because apps can be multi-threaded, and sometimes it takes a while to load data from various sources like internet files, local storage, and so on, the UI test will have to know when the UI is available for interaction. So one way to implement is through of using the idling resources. Okay, so there are objects that can be registered to Espresso before the test, and injected into your application components where multi-thread work is done. So the application will mark them as non-idle when the work is in progress, and idle when the work is done. So it is at this point that Espresso will then start executing the test. Okay, so one of the most commonly used one is a counting idling resources that we used it here, right? So if you remember, we were using some counting idling resources to in our like test my application, like this counting idling resources, um, uh, to mark them not to mark some idle resources, right? So that's the way, and this specific implementation that we are gonna use counter that should be incremented when you want Espresso to wait for your code, right? To complete its execution, and decrement when you want to. So this is how like the counting idling resources will increment and decrement if you want to when you want to let Espresso verify your code, and it should be incremented when you okay, counting idling resources should be incremented when you want Espresso to wait for your code. Okay, when you want Espresso to wait for your code complete its execution. Okay, and decrement when you want to let Espresso verify your code, when you want Espresso to verify your code. Okay, so this is a point to be noted. And when your counter reaches 0, so Espresso will resume testing. And so this is one of the example of using the counting idling resources. Okay, so the application class can be used in injecting the idling resources. Like how can we inject the you see that we injected our application resources in this way. Then we created our idling resources and then we injected our counting idling resources, right? uh, and that's it. Then we finally run our test. Our test is our flow test. This is our test that we are gonna write. We wrote it here. But obviously we need to also do some like setup of idling registry, so how can we do that? We have to do the initial setup before running the test. Before running the test we need to do the setup, right? So, and this is the setup, and the setup will be registry. So you have idle register, get instance, register, and you have your application counting idling resources, and what do you have? That's it. And now your scenario, you don't pass anything more. Your scenario will be your activity scenario. Launch your activity 1 class Java, and then scenario, move to state, life cycle, your life cycle, state resumed, right? So this is our scenarios. And yeah, so this is our initial setup that we have to do to run our test, right? So, and that's it. Yeah, we have to run our test in this way. Let me just comment it down. Okay, so yeah, so this is our simple UI test. We can now just go and run this test. Yeah, we can just run and check this if the UI test is pretty working fine. Okay, we are getting some error here. So what went wrong actually? Failure, test found 1, test run 0, failures 0. Okay, verify flow, test information process crash, check your flow test, verify flow for details. There was a failure, so verify flow, so there was a failure. Okay, so why was there a failure? Okay, we can now try to check out the situation why it failed. Maybe it's because it's a large test. Let me run the test again. Okay, we're still getting some some errors. Yeah, but we're gonna just fix it now. We're gonna see what's happening actually. Okay, let's go to our, maybe there is a problem with our let's see the check the report. Process crash. Okay, flow test for details. So there was a failure with this test. Let me see, because we see that actually it's not you see it's not launching the. Okay, let me just go and see what's manifest. Okay, let me see the all the possible situations here. Exported is export is true. This is okay. uh, let me check my test randomizer. It's our test randomizer, it's a random number, random and random. Okay, let me check my interface. There might be some kind of a randomizer implementation. So my application, randomizer implementation, test random. So we have our test randomizer. Okay, you are not passing any, you don't need to pass anything because it's just the interface, right? So okay, so what can be the problem? Okay, yeah, because it's like 20, there is a 20% chance that actually the UI test pretty work fine, but anyhow the entire situations or the flow was the scenario was what I discussed in the lecture. mm, okay. Okay, so the scenarios can be okay, let me go to my build dot gradle. Let me remove this. Let me remove also this one. Let me sync it down. We rerun the test again. Max snapshots for tail. Test options: emulator, snapshots, failures, external sources. Okay. Okay, actually what am I gonna do? We gonna run the test by the terminal. Clear down, context check. Okay, so we have actually restore activity. Okay, let's go step by step and check out each and every concept. Okay, So we have our activity, we have our second activity like activity 1 and activity 2, we have our application class, and finally we also have our randomizer and synchronizer classes, right? So let me go to my synchronizer, like my synchronizer class, this interface. It's pretty doing well. uh, I don't see any problem here. So what can be the problem is, like, let's go to our test synchronizer. So our test synchronizers are pretty much working fine. And what else, for our test randomizer is also okay, and you're testing your applications is pretty fine. And so let's go to finally our test, counting idling resources. You launch your activity and move to a state. Actually, our activity one, this is not particularly getting run with our performing the click. Okay, so let's sync it down and let's try to run the test again, guys. Yeah, because like UI tests are pretty like not so like there is only 20% chance actually that if the test runs, you have to run it multiple times. uh, and check the test results. So but we have to wait until the button for the activity 1 is clicked. But in my scenario, we didn't even see if the test run 0 failures. That's one failure. Test instrumentation process crashed. Five flow. Let me just uninstall the application and run it again. Custom test runner.